Okay, so for the next, between now and 11 to 15, we're going to open the floor for questions about any of the research announcements, or if we have totally confused you, we're happy to try and unconfuse you. If you'll come up to the microphone either here or in the overflow room to ask questions so that people can hear the questions, we'd appreciate that. And then whoever is the appropriate person will answer them. I do want to say a couple of things just to start to clarify, because after I talked and then listened to the NIH guys, I realized, wait a minute. Wait a minute in that. Besides the implementation partners that you've met here, most of whom have hardware, there is a lot of hardware available that can be used for research for the NIH announcement or any of these other announcements that may already be on board, or maybe NASA-owned hardware or international partner-owned hardware. All of that hardware can also be made available for the any of the research announcements that we discuss. In those cases, the implementation, NASA will make, for the NIH announcement, NASA will make that hardware available. And in that case, what the implementation partner is doing is more of a service provider instead of also a hardware provider, and they're doing all the paperwork that goes with spaceflight integration. And what we have done in those cases, or what we did last year, was, especially if it's an international partner, we drafted a letter between us and that partner to add to the application that said, yes, we're aware you want to use this international partner's piece of hardware, and we've talked to them and we can work a barter for that. So if you get selected, then we'll go do a formal, we'll formally add this to the barter and make the agreements that we need to make. If it's a NASA-owned piece of hardware, then we basically just kind of blanket have said we will make NASA-owned hardware available. If those proposals get selected, we'll probably end up drafting a Space Act agreement with that investigator to provide that hardware to them, so that they and their implementation partner can do the paperwork and everything they need to do on it. We'll fly it, bring it back, and then NASA will take back the hardware at the end of the research period that NIH has funded.
And so, Marybeth, you intend to make those more formal agreements during, say, Phase A studies after the initial selection, or in later phases? Where do you see that happening?
With the NIH announcements, we'll probably do those during the UH2 phase. They'll award, and then we'll go start doing the paperwork to either make the barter with our partners or to provide the NASA-owned hardware, because they'll need it to do their UH2 ground phase in a lot of cases.
So, Marybeth, is there, a while ago, years ago, there was a program called PIG that came out of the biotech program, which allowed for the use by a ground-based investigator to use some of the hardware to develop familiarity with it. Are there still any kind of similarities for the hardware you're discussing? This goes back to the Glenn Spalding era.
Not at this point in time, but on a case-by-case basis, if a researcher needs access to hardware to develop protocols or whatever, we can make that available. But again, that'd probably be as part of the application or right after the award process. The other comment I wanted to make is, when I talked about the broad agency announcement, I mentioned, this concept of having implementation partners on call to help out with different research areas. The one clarification or one caveat, if the research area you're interested in is covered by one of our MOUs with another government agency and they choose not to fund it because they don't find it scientifically meritorious, then you're not going to be successful applying to the BAA and saying, well, NIH didn't fund my idea, but if I send it into the BAA saying we're not looking at science merit first, we're considering it in those that we fund, but it's not our prime driver as it is in these other calls. If it's a research area that's really covered by another government agency's mission and we have MOUs and are working with them, we're going to expect that your applications go through that other government agency, be it a security or a DOD type space experiment. We wouldn't entertain those through the BAA. We'd expect them to come through the DOD CERB. we wouldn't entertain, things that improve life on Earth that could go through the NIH call under the BAA. We would be looking for things that are in areas where we don't have agreements or we don't have any partnerships with other agencies, or maybe there is no real agency that has that mission. But I just wanted to clarify that. So if you don't make it through NIH, it's not going to do you any good to go ahead and send it to the BAA. So that's were the only points I wanted to bring up after Kim's talk, because I wanted to make sure we didn't confuse people. So questions? And if you come up to the microphone in the middle of the room, that would be helpful.
Marybeth, speaking to the point you just made, what if there's an MOU in place like the one between NASA and USDA, but USDA hasn't been forthcoming yet with a call?
Yeah, I think in those cases where USDA hasn't put out any kind of solicitation, that we would entertain those. We'll work with USDA for scientific review to make sure, we'll engage them on the science merit review, because they are the experts and NASA really isn't the expert about, plant growth or animal health or whatever. And we'll use the MOU that way, and if they deem it scientifically meritorious, then we would look at whether there's a way we can partner with that one. Similarly, HRP has their call, and there's cases where we've actually gotten proposals against the standing announcement of opportunity where people are bringing their own funding to the table, but the research they want to do is really in HRP's, in the human research program's mission. And so what we're doing is we're sending those to the HRP team to evaluate and see if it's something that they're interested in supporting within their mission before we decide if we're going to use the NASA resources to enable that flight or not.
So if I could follow up from the national lab perspective then, is there still a dialogue between USDA and NASA, or you're waiting for USDA to step forward?
Well, there's USDA is in the middle of a massive reorganization, and that's what's really held us up. We had multiple discussions after the MOU was signed, and then with the new administration, they've been getting totally reorganized, how they do intramural research, how they do extramural research, and they have not been able at this point to even consider putting out any kind of call like NIH did. And so, if there are ideas, then we'll contact our USDA colleagues and evaluate those. But I don't foresee right now, until they've kind of figured out where they're going and what they're doing. We need to go reestablish some contacts and figure out where the right place is with the new organization that's being set up.
Is the Dragon the only down mass capability we're going to have after the space shuttle will be decommissioned, after STS-134?
Yes, that one's easy. Assuming you mean recoverable down mass, yeah. There's lots of down mass. It just doesn't actually get all the way to the ground. Yeah. We differentiate.
Well, we need to be precise.
But Dragon, SpaceX is expected to fly 2 to 3 times a year, and it has a significant down mass capability. And seeing when shuttle retirement was announced, the space station program went into a mode of, okay, build and burn, expecting everything to, all the equipment, the replaceable units, the filters, the spares, all those to be burned up. So they've taken an approach to expecting not to get any hardware back to be refurbished and reflown. So they're in pretty good shape, and payloads actually has the edge, or utilization has the edge, and we need samples down, we need different things down, and we can't afford to have it burned up. So we kind of get first rights to down mass, I guess is how I might get an argument from Suffredini with that, but we're better off than we would have been, because they've built so many spares that they can afford to let theirs be unrecoverable down mass, whereas we can't.
This is just a point of, I'd like to reiterate this. With respect to the format of the application to the NIH, you provide 30 pages, which is longer than any of the other formats, 12 for the regular one now and 25 for the past one, so to speak. Is that because the implementation group is going to be included in that description?
It's because that the program directors involved got to keep the number of pages long like they like it. So you have 30 pages. The
Yeah.
reason is that bureaucratically is the UH2, UH3 mechanism is not bound by the rules of 6 and 12 pages. So the program directors thought that yes, due to the complexity of the work, it's warranted to have 30 pages, in particular the multiple phases involved. I'll let John comment on that as well from a programmatic perspective.
I really don't have anything to add except that you got to cover 3 phases, the milestones being in between.
I think we ended up giving you guys some additional language. I think you put out a notice to the FOA that kind of clarified what we were looking for in the NIH proposal so that we could do the feasibility assessment that we are involved in after they've done the science review. So I don't know if that's in there or somewhere else.
Yeah, that question came up while you were trying to finish your slides, on time. Sorry. That there was some additional information that, in hindsight, NASA wanted to make more timely funding decisions, and so we were writing up a notice, but Dr. Jessup and I weren't sure if that physically went out yet, but that's at least in process, and that notice, there will be a link to that notice in the FOA, in the initiative, when it comes out.
If there isn't a link, and nobody's perfect, I do think that you can go to the NIH guide and put in NASA as a key search word, and you should then be able to get all of the NOTs, the notices, that are related to this particular FOA.
Let me ask a question. When it comes to your announcements, do you also put them in federal business opportunities? No, you don't. Okay.
No. This is a grant solicitation, and so therefore it does not go into Fed Biz Ops, which is for contracts only. Okay. So while this is a collaborative agreement, a U mechanism, it is not a contract.
That's interesting. In the Science Mission Directorate, because most every announcement does involve contracts, even the grant mechanisms, there are some people that we just have to do contracts with. We do have all of our announcements in the federal business opportunities, so that's a place to subscribe to, at least for Science Mission Directorate announcements.
Well, and
in addition
that's
to
also where ours
Inspires.
go. Well, ours
Okay.
go into Fed Biz Ops 'cause they tend to be contracts.
Okay, so that's one area to subscribe.
You get to hold it until you have to.
Okay.
For an NIH application, and if the implementation part is part of the application, how is the implementation part evaluated in the end? Is effort cost of such equipment built provided by an implementation partner already judged at this phase?
The review of that is really based on what the PI, the applicant, writes and describes. And one of the things that is critical is also that the budget be pretty close to what the budgetary amounts are for UH2 and UH3 as mentioned in the FOA. So and this was part of what I was trying to get at in terms of sort of assessment of feasibility just to do the experiment, in that the applicant really has to work with the partner and demonstrate that the applicant can use the partner's equipment and has, at least in some ground-based experiment, I think, in order to get a good review, demonstrate proficiency for that person's experiment within the implementation partner's sort of equipment and approach. So I really think that's important. For instance, we're all used to, as research scientists, growing things on polystyrene, tissue culture, plastic. If you want to put something in space, more often than not, it's got to go into a Teflon-coated bag. The amount of change that actually generates to how cells are grown, what happens, that sort of thing, has really got to be taken into account by the applicant, and the applicant should at least demonstrate that with this sort of shift in milieu, that their experiment still has a chance of testing the hypothesis that's postulated. So it is a bit of a long-winded answer. I'm not sure that the implementation partner needs to fully describe all their engineering facilities, et cetera, but that the applicant has to demonstrate really working with that partner and having a partnership and collaboration with them to use their equipment. Does that answer your question?
It certainly answers a part, but going further really is at a certain point cost will play a role. And at NIH, a space experiment, is it compared to all the other NIH experiments not going into space also by costing per experiment?
That's why cost is important, and it is important as a strategy for the applicant to get through the institute and have the institute support the application, even if it is exceptionally meritorious, is to make sure that the costs are in line with what is in the solicitation. And you're expecting those costs to cover the implementation? Yes. Oh, yes. No. That's a total direct cost. So the implementation partner can't bill separately, and the applicant has to include the implementation partner's cost within the budget that they submit, which has to be within the total direct cost that's mentioned in the FOA. So that's another reason why it is extremely important for the investigator, to the extent that they can, to use equipment that has already been made and not to be developing new hardware. Not only is there the cost issue, but when you develop new hardware, you also have to get the appropriate legendary number of approvals, okay, for flying in space. Oh, shut up.
So this is where using, as Kim said, using existing hardware where all you have to do is either certify it for that experiment or perform, minor updates to safety data packages and things, makes that much more cost effective. Building new hardware is probably not within the scope of the NIH numbers as far as what they've set aside for this FOA. With the international partner hardware, what's critical, or what it depends on, is whether we already have existing rights to that hardware in some way as NASA, or whether we can add it to existing barters, or whether we have to put it on top of existing barters. All of those are possible, but that there's no cost to use that. We work that out through our barters. The cost then for either that or the NASA hardware is that service, essentially that service of paperwork that some of these implementation partners can talk to you about, who just do that kind of paperwork for a living. And so those tend to be slightly less expensive than when you're using somebody's hardware, but not necessarily. When we go through the evaluation process, NIH looks at the overall cost and makes sure it's within their ideas of what's appropriate for the FOA, and does the science review, and then they send the top however many to NASA, and we look at them for two things. What we owe NIH is just yes, we can accommodate it, we have power, we have cooling, we have, it's not 8 billion years of crew time, those kinds of things. What we also did, though, is we went through the costs for the implementation partners, which were fairly easy to break out the way the proposals came in, and gave them some heads up on, that's about what we've spent on this kind of thing before, or that seems low, or that seems high. So they at least knew whether they had a cost risk, or whether they were in line with this kind of stuff that NASA has spent on this before. Does that help?
That does, yes, thanks.
As far as the space station as a national lab, we've heard all sorts of information about its capabilities and things. I'm a little bit interested in questions about capacity and throughput. I mean, in other words, if you have two projects that are equally meritorious, technically, is one that is bigger, less likely to get, or is one that's going to take longer? Those kind of questions.
So there are two ways to approach that question. One is what the total capacity is for transport, and then the other is how would priority calls be made should things be limited. For those of you that have flown in space before, you flew on ISS perhaps while we were assembling ISS, and utilization was not the top priority. Assembling was the top priority. And during that period, we had payloads that sat on the ground waiting for a launch opportunity, for example, for 3 or 4 years. That backlog is completely gone. Everything someone's building now is build, ship, and shoot, pack, ship, and shoot. So there is unused capacity. We've turned back over to the ISS program so they can see if there are any other spares they can come up with, about 800 kilograms so far this year that we could have flown science with that upmass had there been science developed and available. So those resources fluctuate over time. And right now we're in a situation where we're very upmass rich, and our crew time is relatively balanced. So there's not a lot of extra crew time, but we've been able to get most of our planned research without too many significant hardships. So we expect the crew time to actually get even better than it is right now over the next few years, and as we get to full 6 crew ops with no assembly left.
Julie, I noticed on one of the charts that there was only 35 hours a week for available crew time, which with 6 crew doesn't seem like too much.
It's 70 hours a week if you count the Russian crew time for research. So, we have a crew that's divided 50-50 between Russian crew members and what we call the U.S. operating segment, which is U.S., Japan, Canada, and Europe. And we cooperate with the Russians significantly all the time. Every partner has flown something through every other partner's resources under the different arrangements that we make. But when we talk about 35 hours a week, that's 35 hours a week that we as NASA integrate for that international partnership of the component of the partnership that includes Japan and ESA and CSA, Canadian Space Agency, and European Space Agency. So totally, there's 70 hours a week. We can make trades and have made trades with Russia in the past to get more crew time when we needed it. What we're thinking right now is that it looks like that amount of crew time is about sufficient, including moderate national lab users on top of all the NASA-funded users. And then we continue to make those trades as we go forward in the future. Now, there was one other component to the question, which was priority. In other words, does it help to be small? Does it help to be big? On general principles, it always helps to be small because you can fit in a corner that somebody else can't use. And so as we work through the priority list, something large might get postponed, say, by 1 flight because it can't be accommodated just because of its volume or just because of its mass and the particulars of the way something's getting packed. It's sort of like when your family's going on vacation, if you all use your big suitcases, somebody's not going to fit in the trunk, but if one of you uses 2 small suitcases, then it's fine. And that's essentially the kind of packing issues we sometimes get. However, the unpressurized upmass and the pressurized upmass are not exchangeable. So if you're launching in the unpressurized part of the can and going out on the truss somewhere, that's a completely separate prioritization and structure than the pressurized part, because we can't change the size of those two relative to each other. Yeah, that's a good point. And the planning for that is done significantly earlier. So those manifests are potted well 2 to 3 years out. Those manifests are finalized, and we actually carry a working manifest that goes 5 years out for our externals.
Yeah, I wanted to ask you about the access to data sets. It's somewhat difficult to find information on what has been done, particularly experimental data. And I would like to see how can we access this data, analyze something that hasn't been necessarily published in papers, in material science and in biological experiments. If you can refer to that.
So data access for experiments done on the space station are controlled by the sponsoring organization, which means, and then the rules for that are included in the grant or the contract or the Space Act agreement that that sponsoring organization makes with the payload user, with the principal investigator. So for the human research program, for example, all human research program investigators are required to put all their samples in a common archive, and access to that archive is governed by a review process. In the physical sciences, it's governed by different rules if it's funded by NASA. And for example, our Department of Defense users of space stations will have their own rules about what data can be released and what cannot be released. We do keep a database out there that lets you know who the principal investigator was for every single experiment that's ever been done. But there is no central archive because there's no central selecting authority. And access to data in a particular area of interest, like access to most experiments here on the ground, relies on developing good collaborations with people who have collected that data.
This is for either Barbara or one of the NIH representatives. This past spring at Houston's Rice University Baker Institute, there was a 4-day conference on human spaceflight and future life science research opportunities. And it was attended pretty much by the partner communities represented by their administrators, their research teams, and also a lot of their crew members. And one theme which dominated the discussion there was that of export control. So I'm just wondering, with respect to these proposals, are there hurdles that have to be jumped with respect to export control up front? If so, what are they? And if not, when are they addressed?
That's a very good question, and it's something that our researchers have struggled a great deal with over the past few years. In the case of the announcements of opportunity put out by the Science Mission Directorate, it is something that is addressed in the very first proposals. One reason that these proposals take so much time and effort to develop is that we do actually require a full explanation of the entire mission concept. We require the entire science plan, the full implementation plan, including how you're going to deal with things like ITAR and export control. It is something that institutions, they have to rely on their own expertise to deal with, and it really is something that, at least for the Science Mission Directorate, that is evaluated and dealt with at that first proposal. Technical, management, and cost risk, and we evaluate it in terms of risk. That's a major criteria that goes into the selection process.
For the NIH sort of life science experiments, that really is not an issue because, as I understood, ITAR was really more about software, electronics, and that sort of information, which may be more in the satellite side of things. But doing biological research by and of itself is not generally subject to ITAR concerns.
That's a good thing. As it turns out, some spaceflight experimental hardware can be covered. There are certain types of cameras, for example, that are considered to be covered by ITAR. So you do have to take that into consideration and consult with the experts when you're considering proposing. We put a contact in our AOs to help you out on that, too.
there any estimate on when the decadal survey results might be coming out?
Let's see, so there was a decadal survey for Earth science. Each of the 4 divisions in the Science Mission Directorate do a decadal survey with the National Academy of Science. It's actually something that Congress has written into the language. You can see it in appropriations bill, authorization bills. So it's actually now something we're required to do. Congress really feels that the decadal survey process is important for planning the future. So we do them one at a time. They take 2 years. The National Academy, well, it takes a lot of money too. Earth Science did theirs. It came out in 2007. The Astrophysics Division, theirs has been going on over the past 2 years, and theirs is actually due this fall, so it should be coming out. I think the briefings may be happening now. It may be in review. I think they've made their major decisions, but we haven't seen the results yet because it may be at the review stage. In the planetary group, they started their decadal survey about a year ago, so they have another year before the final report comes out. So they're right in the middle. They're right in the middle of studying potential missions, that sort of thing. For heliophysics, we just started the contract for its next decadal survey this summer. So the end result will be 2012. They just announced the members of the steering committee. They're having their first meeting in September. So we just do them every 2-3 years in turn.
And you should also know that there is a decadal survey in microgravity and partial gravity, life and physical sciences. The draft of that was just posted by the National Research Council recently, and so you can find that on their website. Their draft study did not include the priorities that will be in the final study. One thing interesting about that is because of the time frame when that was requested, it is guidance to NASA about NASA's mission. So it is focused on exploration objectives and was partly authored in a time frame where lunar exploration was a major focus. So it's not as broad, perhaps, as some of the decadal surveys on the Science Mission Directorate side in addressing all of the different possible uses, but it is certainly going to be good guidance for the NASA-funded research side of that pie chart we keep showing.
What should you mention, Kim?
I'm sorry, what was the question? We were over here kibitzing.
What you mentioned about the ITAR application.
One of the other things about the NIH FOA is that it is only for domestic institutions, American PIs. The only way that this would come up, and it was not an issue at all in the first round, is that through subcontracts, because this is an American PI, American institution on an American satellite.
So I have a question for Dr. Jessup, based on, hopefully for the audience, based on what happened at our break conversation. So on the NIH initiative, this speaks to the variability of practice at the NIH institutes. On the NIH initiative, some of the institutes say specifically what they're looking for, and one or more of them don't mention specific things that they're looking for, specific work. So how does one figure out, for example, those that mention specific items, is that the only thing they're listed in? And if an institute's listed but doesn't say what they want, how do I figure out what they're looking for?
Good luck, boyo. The main thing is that when an applicant wants to propose an application, they really need to make contact with the program director that is listed for that institute, because that program director will tell the applicant whether their hypothesis and ideas are in line with the missions for the institute. Hopefully the applicant will take that to heart. That was not the case in the first round. for some of the applications. So it is important that if you're going to put in an application to the NIH, because of the vagaries of the different institutes and the way that they handle these kind of funding opportunities, it is important to get in touch with the contact person because they act, hopefully in good faith, as an ombudsman person between the applicant and their institute, and they should give practiced advice as to what will and will not be in line with what that institute will fund.
Just to, in contrast, I can tell you, we don't operate that way. Just to be, and that's good. That's a good thing. In our case, if you call the program officer and ask advice on what to propose, they're going to say, I'm sorry, we're not going to give you advice on how to write your proposal. We literally mean what's in every announcement. And it is kind of interesting. People will try to read between the lines and say what they really mean is X. If you find yourself saying that when you've read at least the Explorer announcement, back off. We really mean every word, literally, and when it comes to the evaluation and selection, we stick by every word, even if the landscape changes. We really do mean it strictly. And so if it's very open, we mean it to be very open. If it's very specific, we mean it to be very specific. And we make sure that our program officers don't give advice because, quite frankly, if you ask me about the Explorers, I can only lead you astray.
So we have the specificness and the generality in a single announcement, and I'll let Dr. Jessup talk. But the program officers don't give research advice. They give advice on guiding work that's relevant to the mission. So if you do this, we would want it. If you do that, another institute may want it, as opposed to you should use this model, look at this marker, and that sort of thing. But it's important to clarify because there could be differences.
That's absolutely right. However, project officers, program staff really do need to help the investigator align their research with what an institution can do and support or tell them to go elsewhere. We are not here, the program staff cannot formulate the questions and the hypotheses de novo, but can say perhaps that you might want to think about changing your hypothesis because the institute can't fund this, but in a related issue that might make this more attractive to the institute.
And just to try and represent some of the other NASA mission directorates, I think you'll find that the Science Mission Directorate, because they have very specific goals, is more able to sort of say, well, read the book and we can't help you. On the Human Research Program side, they lay out very specific goals which change year by year. You can call up the right points of contact there and say, I'm thinking about this, does that fit in your goals? And they'll tell you if they think it fits. On the life and physical sciences experiments, those are quite variable year to year, and those program executives, who I know well, are very open to discussions and approaches because, you know, if they've got a fluid physics announcement out there and you want to bring in something that's on the borderline between fluids and materials, you're trying to figure out how you fit a subdiscipline when all the other disciplines aren't open each year. And so they work quite closely with investigators to help give them guidance.
Okay, if there aren't any other questions, then we'll see if we can go ahead and start with the implementation partners. Justin, if you can get TBE queued up here, we can probably get them started in the next couple of minutes. So let us do that. Move these chairs.